Good morning, everyone. Today we shall see the unit number 2, that is a single degree of freedom systems, forced vibrations with forced vibrations. So whatever we have seen in the unit number 1, that is about free vibrations. So in this unit we shall see the forced vibrations. So first of all, what is meaning of forced vibration? अभी देखो, फर्स्ट ऑफ ऑल फ्री वाइब्रेशन का मतलब क्या है? फ्री वाइब्रेशन मीन्स इट इज वाइब्रेशन वेयर it is happen due to initial disturbance of the bodies. Means in the free vibration, so body will be disturbed with some initial force. पहले स्टार्टिंग में उसको फोर्स अप्लाई करने का, उसके बाद छोड़ देने का. तो that type of vibrations are called free vibrations. Forced vibration means it is when a body, so when a body vibrates under the influence of external forces, then body is said to be under forced vibrations. So when the body vibrates under the influence of external force, means here in case of forced vibration, the body vibrates due to continuous application of external force. So then this type of vibrations are called forced vibrations. So example, if you take the machines, simple examples are, if you say the electrical ringing of electrical bell. So electrical bell में क्या होता है? So when we press the button, so because of that electricity, that is electric force is used for ringing the bell. उसके बाद vibration of air compressors. So I think air compressors are used for to store the air at higher pressure. Okay, so means other examples also you can take, like CNC machines, VMC machines, like automobiles when it is running. Means when the vibrations are due to continuously application of some external force, the force may be different type, like mechanical force, electrical, etc. Then if the application of force is continuous, then that type of vibrations are called the forced vibrations. So there are different type of external excitation forces. Types of external excitation means it is force. First one is periodic force. Periodic means क्या होता है? So the force which is applied continuously after certain interval of time, means properly. So after every second, if you apply the force of 1 kilonewton, means time is after 1 second. 1 kilonewton means every time it is, if it is 1 kilonewton after defined time, then that type of forces are called the periodic forces. Next is impulsive forces, impulsive type of forces. So impulsive force means, so in this case time is fixed, means force will be applied after every second. Example, I am telling example, like after every second, after 2 seconds, after every 3 seconds, like that. But the magnitude of force is go on decreases. मीन्स दिस इज अ काइंड ऑफ ट्रांजिएंट मीन्स क्या होता है? तो उसमें चेंजेस होता है मैग्नीट्यूड ऑफ फोर्स में, बट जो टाइम पीरियड है ना, तो इट इज लाइक सिमिलरली लाइक पीरियडिक फोर्स, बट हियर magnitude is go on decreases. Means force applied every time it is go on decreases. So this type of force is called impulsive type of force. So next is third one is random forces. So random forces means it is we don't know when that forces will be applied, when that force will be acting, and how much magnitude it is acting. So we don't know. Means like sudden failures of the parts going to happens due to random forces in the machines and automobiles. Means here, so some it may be due to breakage of some parts, it may be some due to defects in some parts of the machines and other automobiles, so etc. So because of that kind of things, so sometimes random forces will be applied. So basically whatever the forces that is applied on the different parts, so because of which vibrations are occurs, so that forces are classified into basically into three categories: periodic forces, impulsive type of forces, and random forces. But we are going to study only on by considering the forces are periodic in nature, because so that makes the analysis simple. So just I will give the example of the periodic force, like harmonic motion. It is simple harmonic motion, SHM in short. So this is the how you can represent the simple harmonic motion, that is y-axis and x-axis. So this is the complete circle of the motion of if you take the any vibration. So इसमें क्या है कि so it is a vibration means it's kind of a wave. It's kind of a wave that is. So here you can say x-axis denotes the phase angular displacement, that is phase angle. So angle is given by omega into t. So omega means it is a frequency and t means it is time. Omega into t. So afterwards this is x-axis, sorry, y-axis denotes the, that is omega into t, that is so x of omega into t. Okay, so y-axis denotes the amplitude and x-axis denotes the phase angle. So amplitude you can say, so this from this point to this point, so it is maximum amplitude. So this is called the maximum amplitude. Sometimes it is also called the dynamic amplitude. So in most of the cases it is denoted by a, otherwise so it is denoted by capital X. देखो from this point to this point it completes one cycle. For completion of one cycle, so angle covered, phase angle is equal to 360 degree. For any complete one cycle, so angle is 360 degree. That means it is 2 pi radians. So it will be equal to 2 pi radians. Means why I am explaining you is, so you need to understand what is meaning of amplitude in vibrations. So from amplitude means it is distance measured parallel to y-axis from the x-axis. So x-axis से perpendicularly measure करने का. So at different points. So this at this point, if you measure the amplitude, it is maximum. That is called the maximum amplitude or dynamic amplitude. And phase angle you need to know that. So in free vibration also I have explained the mechanical system. So how we are going to what you can say represent the system for the vibration analysis. So in that case, in first unit there is no free vibrations, because of that there is no forces applied. But here, so it is same like previous unit, like spring, damper and mass. So along with that some force is applied, that is periodic force, F naught sin omega t. So F naught sin omega t. So what is meaning of this is, F naught means it is magnitude, sin omega t is, देखो omega t means it is at this point angle is become omega is equal to omega into t is equal to 90 degree, means pi is 90 degree, sin 90 is 1. Okay, so at this point vibration force applied is become maximum because f naught into sin omega t. If omega t is equal to 1, force applied is equal to f naught. So suppose if the omega t value is equal to 90 degree, then sin omega t becomes 1. So force applied is equal to f naught. Means at different points the amount of force applied is depends on the phase angle. Omega into t means what it is? It is a phase angle, that is pi. Okay. So next, if you draw the free body diagram of this system, free body diagram of spring mass system. So this is accelerating force, so which always acts in the downward direction, and other two forces are called the restoring force and applied force. देखो, this is a spring force. Spring force acts in the upward direction because we are taking the free body diagram of the mass. Okay, so and damper force is also in the upward direction and applied force in the downward direction, f naught sin omega t. अभी देखो, अकॉर्डिंग टू न्यूटन सेकेंड लॉ क्या होता है? सो एक्सेलरेटिंग फोर्स इज इक्वल टू as per Newton's second law. So accelerating force is equal to external forces. So accelerating force क्या है? It is in downward direction, so it is, so that's why it is minus mx double dot is equal to, तो एक्सटर्नल फोर्स कौन सा है? डैम्पिंग फोर्स, स्प्रिंग फोर्स एंड अप्लाइड फोर्स. सो अप्लाइड फोर्स क्या है? टू इन द डाउनवर्ड डायरेक्शन, इसलिए उसको क्या करने का? माइनस लेने का. सी एक्स डॉट एंड के एक्स क्या है? सो दे आर इन द अपवर्ड डायरेक्शन, so that's why they should be plus. So these two are plus, this one and this one are minus. Okay, so again if we simplify this, so we get the equation as a if you bring cx and cx dot and kx on left side, so it will become minus mx dot double dot minus cx dot minus kx is equal to minus f naught into sin omega t. So suppose if you multiply this whole equation by minus sign, then we get the mx double dot plus cx dot plus kx is equal to f naught sin omega t. So this equation is called the equation of motion for damped forced vibrations. मतलब इसमें डैम्पर भी है, फोर्स भी अप्लाई किए. सो दिस इज द इक्वेशन ऑफ मोशन. अगर फ्री वाइब्रेशन है तो क्या होता है? डैम्प्ड फ्री वाइब्रेशन मीन्स, सो इन दैट केस, सो फोर्स अप्लाइड विल बी, दिस वैल्यू विल बी 0. सो इफ यू अप्लाई द फोर्स, so that will be the whatever the applied force. So next is, so analytical solution of forced damped vibration, means how we can make the analysis of the vibrations, so by using different analytical tools. So analytical tools means, in the sense, it is different formula. So by using different formula, so how we can make analysis, so that before we are going to do that, so I will explain you different formula that will be used in the this analysis of the forced damped vibrations. First one is frequency ratio. So what is meaning of frequency ratio is, it is the ratio of applied, it is the ratio of frequency of excitation to the natural frequency. Means it is the ratio of excitation force, means excitation force का जो frequency है to the natural frequency. So every body, every object will be having its own natural frequency. So natural frequency means the frequency at which body starts vibrating with maximum amplitude. So उसको हम क्या बोलते हैं? That is natural frequency. So in this case, so excitation frequency to the natural frequency. This ratio is called the frequency ratio. It is denoted by small r. So next is phase angle with respect to excitation. So phase angle relation with respect to some other parameters like frequency ratio and damping ratio. So it is given by tan pi is equal to 2 zeta into r by 1 minus r square. अभी देखो 2 zeta into r, zeta means it is damping ratio, so it is equal to c by cc, that is damping factor divided by critical damping factor. Critical damping. Next is r means it is frequency ratio, just we have seen in the previous slide. So by using this formula, so if any of two parameters are given, otherwise if you know any two parameters, so we can find the third parameter. So pi means it is a phase angle. So next is amplitude of vibration. So in previous slide, so in one of the slide I explained, so what is meaning of amplitude. So amplitude is very important, because if the amplitude of the vibration becomes high, then failure of the components are going to takes place. So that's why, so we always try to contain the amplitude of vibration of the different parts in the machines. So if you want to find the amplitude at any different point, so it is given by x is equal to small x, it is, we say it is x small x or xp, x suffix p, f naught sin omega t minus phi divided by k into square root of, in the bracket 1 minus r square, again bracket complete whole square plus 2 zeta into r whole square. तो इसमें in this case, so k means it is a spring constant, r means it is frequency ratio, and zeta means it is damping ratio. So it is this formula is used to find the amplitude of the vibration at a different phase angle. अभी देखो ओमेगा टी माइनस पाई, अगर सपोज if you want to find the maximum amplitude or dynamic amplitude, so which is denoted by capital X, so it occurs when sin omega t minus phi is equal to 1. देखो this magnitude become this value of amplitude become maximum when the sin omega t minus phi, the sin value become 1. So that is sin omega t minus phi is equal to 1. That means maximum amplitude is given by f naught by k into square root of 1 minus r square whole square and plus 2 zeta r whole square. So here is a bracket, left side also here, so it is not mentioned here. So you just understand that. So before 1, so here is also bracket, like here how it is. So into bracket 1 minus r square whole square. Same way here also into bracket 1 minus r square whole square. So bracket here is missing. Okay. So these formulas are used to, this formula is used to find the maximum amplitude of vibration. So which is also called the dynamic amplitude. So next is magnification factor. So sometimes it is also called the magnifier. So magnification factor means it is the ratio of amplitude of steady state response or dynamic amplitude to frequency deflection. देखो dynamic amplitude or maximum amplitude, so just we have seen before. So magnification factor is given by a by x naught. A means it is, capital A means it is, so amplitude of steady state response. So instead of A, so we can also use the capital X, that is maximum amplitude. So in some of the books they have used the capital X, in some of the books they have used the capital A. So we can use any symbol. So it is equal to formula क्या है? So magnification factor is given by 1 divided by square root of 1 minus omega by omega n square into bracket whole square plus 2 zeta into bracket omega by omega n whole square. So if you represent this in terms of another symbol, magnification factor is denoted by this symbol, that is called ohm, is equal to 1 by square root of 1 minus r square whole square. R means here it is frequency ratio. Frequency ratio means it is omega by omega n plus 2 zeta r whole square. Again it is given by x, capital X is equal to f naught by k into omega. So this symbol, this formula, it is we can use to find the different values when we know the other values. So next is maximum value of magnification factor. देखो maximum value of magnification factor is given by omega max is equal to 1 by 2 zeta into square root of 1 minus zeta square. So I think you may not able to see this formula. 2 zeta into the bracket 1 minus zeta square. Okay, so this formula is used to find the maximum magnification factor, that is maximum value of magnification factor. So next is we shall see the charts, so which we need to understand two important charts. So that is magnification factor and phase angle versus frequency ratio. मीन्स मैग्निफिकेशन फैक्टर एंड फेज एंगल, इसके साथ फ्रीक्वेंसी रेशियो कैसा चेंज होता है, हाउ इट वेरीज. अभी देखो फर्स्ट ग्राफ है कौन सा है, सो दिस इज सो magnification factor, that is amplitude ratio, so which is also called magnification factor, and x-axis denotes the frequency ratio, that is omega by omega n. So you can see here, so when the magnification factor so 1, then frequency ratio is 0, frequency ratio is 0. So that is, you can see when there is magnification factor is more, so as the magnification factor increases, you can say for a different damping ratio. अभी देखो these curves are drawn for the damping ratio, different damping factor. So zeta is equal to what, c by cc. So if this curve is for zeta is equal to 0.1, this curve is for zeta is equal to 0.3, so on. मतलब क्या हो रहा है इधर, जैसा जैसा डैम्पिंग बढ़ रहा है वैसा वैसा मैग्निफिकेशन रेशियो इज आल्सो डिक्रीजिंग. मीन्स क्या होता है, सो इफ यू इंक्रीज द डैम्पिंग, so amplitude of vibration is going to decreases. So that is the indication that we can understand from the this particular graph. So next is phase angle versus frequency ratio. So y-axis here indicates, denotes it is phase angle, and x-axis denotes the frequency ratio. So again when the phase angle is 0, frequency ratio is 0. It's interesting here is when the phase angle is 1, sorry, when the phase angle is 90 degree, frequency ratio is 1. So these are also drawn for the different damping ratio values. You can observe here, this is for damping ratio 0, and next curve is for damping ratio 0.05, 0.25, 0.51, 2, etc. So with respect to that is phase angle. So here also you can see when the frequency ratio increases and the phase angle increases. From this phase is for the frequency ratio more than 1 and phase angle is more than 90 degree, and this phase is, that is frequency ratio less than 1 and phase angle is less than 90 degree. Means we can understand, so relation between the phase angle and frequency ratio and and magnification factor and frequency ratio. इधर देखो amplitude ratio means it is a magnification factor only, otherwise magnification ratio. Sometimes it is also called magnifier, so don't get confused between different terms. So next is transmissibility of force. So it is very important. So it defines it, what you can say it, it is very important to avoid the vibration transmissions. Transmissibility means it is the ratio, or देखो transmissibility ratio, it is also called the isolation factor, is the ratio of force transmitted to the foundation Ft to the force applied or excitation force. So इसका मतलब सिंपल अर्थ क्या होता है, सपोज दिस इज ए वन ऑब्जेक्ट. सो इफ यू टेक एनी वन ऑब्जेक्ट, इफ यू टेक एनी वन ऑब्जेक्ट, सपोज मैंने इधर 10 किलो न्यूटन फोर्स अप्लाई किया. सो ये जो ऑब्जेक्ट है, तो इसने क्या किया, 5 किलो न्यूटन को सिर्फ ट्रांसफर किया, 5 किलो न्यूटन एब्जॉर्ब किया. So if you take one object, so if I apply the force of 10 kilonewton, so if it transmits only 5 kilonewton below that, मतलब क्या हो गया, 5 kilonewton absorbed by this body. तो इसलिए so it is, what is transmissibility? It is the ratio of force transmitted to the foundation. मतलब अप्लाई कितना किया, 10 किलोन्यूटन, ट्रांसमिट कितना हो गया, 5 किलोन्यूटन. Force transmitted means 5 by 10 transmitted to the applied force 5 by 10. So इसलिए transmissibility ratio कितना होता है, 0.5. 5 by 10 is equal to 0.5 means transmitted to the applied. So this ratio is called the transmissibility ratio. So this term is called the transmissibility of force. Means ट्रांसमिसिबिलिटी रेशियो जितना कम होता है तो उतना फोर्स ट्रांसफर कम होता है. तो उसका मतलब क्या है, उसका जो आइसोलेशन कैपेसिटी है, मतलब डैम्पिंग कैपेसिटी, दैट इज मोर. मतलब क्या होता है, व्हेन देयर इज अ वाइब्रेशंस, सो टू अवॉइड द ट्रांसफर ऑफ वाइब्रेशंस फ्रॉम वन पार्ट टू द अदर पार्ट, सो व्हाट वी डू इज, सो वी यूज द डैम्पिंग. सो डैम्पिंग का व्हाट इज एम ऑफ डैम्पिंग, टू avoid the transmission of avoid or reduce the transmission of vibrations or forces. So that should be the function of dampers. Okay, so transmissibility ratio is given by the force transmitted to the force applied. It is the ratio of force transmitted to the force applied. So it is also given by the omega into bracket into the square root of 1 plus in the bracket 2 zeta r whole square. So by using this formula, so we can easily find the transmissibility ratio. Okay. So again we shall see the two more graphs, that is transmissibility and the phase angle versus frequency ratio. So phase angle versus frequency ratio, so that just we have seen so magnification factor and phase angle versus frequency ratio for different damping values, so that we have seen in the previous slides. So in this slide, so we shall see the transmissibility and the phase angle versus frequency ratio for different TR values, transmissibility ratio values. Sorry, so I can say that, so here also we are going to see the graph of transmissibility and phase angle versus frequency ratio for different damping values. that is different values of zeta. So here also we can see here, देखो frequency ratio is equal to omega by omega n, and y axis denotes the display transmissibility. Displacement transmissibility means it is how much displacement is it transforming to the applied one. So here we can see that when the frequency ratio is 1, when the frequency ratio is 1, that is transmissibility is more, transmissibility is more means a ज़्यादा फोर्स ट्रांसफर करता है when frequency ratio omega by omega n is equal to 1. मतलब transmissibility damping will not have much impact when applied force, applied frequency is equal to natural frequency, means applied omega by and omega n is, if it is they are equal, so उसका मतलब क्या होता है, frequency ratio r value will become 1. So when the frequency ratio is 1, so transmissibility ratio is maximum. So these are the different for different values of zeta. And again one more term, when the r value is equal to square root of 2, when the r value is equal to square root of 2, then transmissibility is equal to 1. When r value is equal to square root of 2, transmissibility value is equal to 1 irrespective of zeta value. Zeta value कितने भी होने दें, when the r value is equal to square root of 2, then transmissibility ratio is equal to 1. So these values are important. Again this is for the phase angle versus transmissibility ratio. So again the curves or graph is drawn, phase angle versus frequency versus phase angle. So it is also that we have seen in the previous slides. Okay, so at the 45 degree, at 90 degree you can see, at 135, 180 degree for different values of zeta. So you can observe how the changes are going to occur. So here important, you need to remember these 2 points. When r is equal to 1, TR is maximum. When r is equal to root 2, TR is equal to 1. So these 2 are important values here. So next is vibration isolation, means, so what we have seen in the previous slides about transmissibility ratio, so that is depends on the vibration isolation, means how we can isolate the transfer of vibration from one part to the another part by using the damping material, dampers. So vibration isolation means it is the process of reducing vibrations of machines, and hence reducing the transmitted force to the foundation. मतलब एक पार्ट से दूसरे पार्ट को हम वाइब्रेशन ट्रांसमिशन अगर कम किया तो उसका मतलब क्या होता है, अल्टीमेटली जो फाउंडेशन को जो वाइब्रेशन ट्रांसमिटेड है वो ऑटोमेटिकली कम हो जाता है. सो एंड हेंस reducing the transmitted force to the foundation using vibration isolating materials such as cork, rubber is called vibration isolation. Isolate means to prevent transfer of vibrations. Vibration isolation means it is to avoid the transfer of vibrations from one part to the another part, in simple term, by using different techniques. So sometimes we use some materials, sometimes we use some machines, some external forces, so to prevent the transfer of vibrations. So this mechanism, this process is called the vibration isolation. So we use different materials, like we use springs, so we use dampers, we use what you can say, pads, rubbers, cork. So we use many other materials, so to prevent the transfer of vibrations from one part to the another part. Because so control of vibration is very important. So otherwise what happens is, so there may be failure of components or different parts. So that's why, so we always need to make the proper analysis of the vibrations, so before the design becomes final. Okay, ठीक है. Thank you all. So in the next lecture, so if you have any doubts, whatever we have covered today, so you are most welcome to ask any doubts if you have any doubts. So again, so I will going to share you the some another video to you people, so about critical speed or whirling phenomenon. So it is not prepared by me, so it is by some other faculty, so it is from some other academy, so which is I've seen that video, so it's very nice, so you can understand much better than what I explained it now, what I am explaining. So that's why, so you also watch that video. So that completes our, after that, so it will complete our unit number 2 theory, complete theory. So in the next lecture, so I will going to solve the problems on the unit, in the unit number 2. So in next one lecture, so I am going to complete the, so different variety of problems from the unit number 2. So thank you all. So I'm going to signing off. So bye, take care.